Today we're going to talk about the request-response cycle, or what I call it, what happens when you type something in the address bar where you shouldn't really be typing in. So what actually happens when you type an address into that URL bar at the top of the screen? We're going to talk about that today, and I want to warn you, this lecture is kind of heavy on acronyms. And I'm not saying you need to memorize them all, but I really feel like it'll give you a sense of empowerment to know what it is when people drop these terms when they're talking to you. So we're going to start off by talking about networks. The first one we're going to talk about are LANs, or local area networks. Almost everyone has experience working with LANs. If everyone in your office shares a printer or maybe two printers, then that means you're all connected on a network. And that network allows you to share services. Now, local area networks are, as we said, local. They tend to be in the same building or maybe in the same floor of a building. Wide area networks are when you take multiple local area networks and connect them together. So perhaps you want to have offices on the East Coast and the West Coast, and you really don't want anyone to be able to connect unless they're part of your business. Well, then you would connect the local area networks for your business. Networks can be confusing because it often seems like everyone is connected to one big network. But think back to different movies you watch where someone needs to break into the building in order to get the passwords. They're running their own private network. The internet itself is the largest wide area network that we have. Because we have these networks, we have something called client-server relationships. Servers are these powerful machines that hold your shared resources. So there's one machine that can be controlling multiple printers, or one machine that actually holds the file that 6 or 7 of you are all editing at the same time. Servers are always connected to the network. They need to be, because otherwise people can't get their work done. Clients are the machines that people are using for personal use. Their laptops, their phones, etc. As we all know, unfortunately, sometimes we're not connected to the network, but that doesn't break anything. The request-response cycle is what happens when you, the client, requests a page or a service from a server. In our case, when we talk about HTML5, the server responds with the appropriate file or files. So how can we get this to work? When we talk about typing things into the address bar, we talk about typing in URLs. And all URLs have 3 parts. They have a protocol, which tells the computer how you want to connect, the domain that tells the computer where to find the document you want, and of course the document, which is which specific file you want. So even though most web pages are made up of multiple files, you kind of go in and ask for the main file name, and the browser takes care of the rest. You've seen a lot of different protocols already without even knowing it. Almost all of you, I expect, will have used HTTP, which is called the Hypertext Transfer Protocol, or perhaps HTTPS, which is a secure version of the Hypertext Protocol. There are others, though. FTP is a way to just transfer files. Ghost was another way to transfer files back in the past. We're going to focus on HTTP for right now. This is why many browsers, when you originally type them in, they start with HTTP. If you skip that, it's okay. Most servers will have a default protocol that they go back to. Again, that's probably going to be HTTP, unless it's your bank or some other financial network, which will use HTTPS. The domain name is the fancy name of saying, hey, this is where I want to connect to. So you've seen a lot of them. There's umich.edu, or google.com, or wikipedia.org. Right away, the umich, the Google, and the Wikipedia identify the company that you're trying to connect to. Each one of these, though, as you know, has a different, what we call a top-level domain. The .edu, the .com, the .org. In the early days, it was very easy to just grab any top-level domain you want. However, we now have ICANN, and they're in charge of assigning names and numbers for the different organizations that you might want to go to. You can go ahead and find out about all the different types of domain levels if you follow this link down here. But for right now, I want you to realize that typically .com is for business, .edu is only for affiliated educational institutions, and .org tends to be for nonprofits. Again, people find ways to get around, but it's ICANN's job to help you best search the web. Each one of these domains has an associated IP address. One of the reasons that the internet does so well now is that we have something called the domain name server. When the internet first started, you had to remember that 16-digit or 4 sets of 3 numbers to find out where things were located. You didn't get to type google.com. You had to type in something along the lines of 181.25.06.19. I completely made that up. Please don't type it in. I don't know where it'll take you. All right? But you had to remember the actual number. The IP protocol version 4 is able to represent 4.3 billion different combinations, which is really helpful. What we have now with the domain name server is when you type up your name, it will go and figure out which of those 4.3 billion different addresses you actually wanted to go to. In addition to the protocol and the domain, the URLs can also specify a specific document that you're looking to get. So in my first example, I have my protocol and my domain, and I specified that the document I want is contact.html. In my second example, I went ahead and added a folder name to that as well. So you're not always looking just at a document. That document might be a few folders down along the lines. If no document is specified, that's not a problem. The default document is returned. Because I know that we've all gone to different sites and not specified the document. It's pretty common to just go to wikipedia.org or yahoo.com. If you don't name the document, the convention, or the thing that most people do, is that the file called index.html will automatically be loaded. So we've done that. We've gone ahead and we've typed in a full URL, the protocol, domain, and document. What happens next is that that domain is sent to the domain name server and the IP address is returned and sent to the browser. The browser then takes that information and sends off what's called an HTTP request. When it sends out that information, even though we've only typed in things in the URL, there's a lot of hidden information that's going on in our request. So for instance, there's special header information that your computer might be sending. You might be sending cookies. Maybe you just filled out a form to buy something great online, so it's sending that information as well. Once the server receives the request, it's going to return files. And here I've tried to make it clear that it's not returning web pages. When people think of web pages, they think of something that's nicely formatted and kind of already put together. But the server isn't concerned with what's going to happen to those files. It doesn't know if a browser is requesting them, a screen reader, a bot. All it does is return files. It is up to the browser to decide what to do with each one of those files. Sometimes you type in a URL that just doesn't exist, or the server is down. If that happens, the server sends back an actual web page that's going to show the error that it sent. So for instance, 404 might mean that you misspelled the document. 500 might mean, oh, nope, the server is actually down. So let's look at an example of what happens when I type in http://si.umich.edu into the address bar. What's going on at the high level is I'm initiating the request response cycle. At a lower level, the first thing that's going to happen is that the browser is going to use the domain name server to say, hey, where is si.umich.edu located? The DNS is going to return the IP address that's associated with this entity. The browser then, armed with where it needs to go, is going to send an HTTP request saying, can you please send me your default document? The server finds the default document and sends it back to the client. Now, most people think that that's the end, and the browser is just going to display the file that's sent back. But what really happens is that the browser takes the response and renders the HTML code as a nice graphical representation. Many times, it needs to repeat steps 3 and 4 over and over again before it can be finished, because you're not just getting one file in this example, you're also getting images, style sheets, and a lot of different supporting information. So I just want to give you a few additional notes before we moved on and finished this slide. The first is I wanted to give you a live example of that slide I just did to give you a little bit more understanding of what's going on in the request response cycle. Here's about the most simple example I can give you. I went back to one of our much earlier files, the template.html file. And I'm going to go ahead and load it up here again. But before I do that, I'm going to bring over here a special tool that you can get by doing inspect element. When I reload the page, you can see that I requested the file